Hello everyone. This session is about Norton's theorem. This theorem was given by an American engineer, Edward Rory Norton. Before solving problems using Norton's theorem, we should first understand the statement of Norton's theorem. Norton's theorem states that a linear bilateral two-terminal network can be replaced by an equivalent network consisting of a current source IN in parallel with a resistor R, where IN is the short circuit current through the terminals and Rn is the equivalent resistance at the terminals when the independent sources are turned off. And we can say that Rn will always be equal to the Thevenin resistance RTh. And IN, Norton current, IN will be equal to VTh divided by RTh. That is equal to Thevenin voltage divided by Rn. So from this equation we can write Rn will be equal to VTh divided by IN, Thevenin voltage divided by Norton current IN, or the short circuit current IN. So according to Norton's theorem, a given network having two terminals can be replaced by a current source in parallel with a resistor. Current source is the IN, Norton current IN, and resistance is Norton resistance R. Then explanation. So let's consider a simple circuit like this, having a voltage source V and resistors R1, R2 and R3, and load resistance RL is in between terminals A and B. The first step is to remove the load resistor RL and calculate IL. So the load resistor RL is removed and a short circuit is placed between terminals A and B. And current through that short circuit is the Norton current IN. Now, using the circuit parameters, we have to calculate IN, which will be the Norton current. Then second step is replace the independent sources and calculate Norton resistance RN. So, the voltage source is replaced by a short circuit and the circuit is redrawn like this. And from this circuit, we will get Rn is equal to R1 and R2 are parallel, and that in series with R3. So the Norton resistance will be equal to R1 into R2 divided by R1 plus R2 plus R3. And if the network contains both dependent and independent sources, Rn can be found out using this relation, Vth divided by IL. And if the network contains only dependent sources, Rn will be equal to V divided by I, where V is a non-voltage source and I will be the current drawn from that voltage source by the circuit. Third step is draw Norton's equivalent network. Norton's equivalent network will contain Norton current source IN in parallel with RN. Then these are the two terminals A and B. Between A and B, the load resistor RL is connected. Now the current IL can be found out using current division rule. IL is equal to IN, total current. IN into IL is equal to total current. This is the total current IN. IN into resistance of other branch divided by total resistance. Then steps to be followed in Norton's theorem. First step is to remove the load resistor RL and put a short circuit across the terminals. Then second step is to find the short circuit current IN. Third step is find the resistance RN as seen from terminals A and B. Then replace the network by a current source IN in parallel with resistance Rn. Finally, find out the current through the load resistor using the relation IL is equal to INRN divided by Rn plus Rn. Now let's move to a problem. Find the current through the 10 ohm resistor. Find the current through the 10 ohm resistor. Then first step is to calculate IN. In order to calculate IN, I am redrawing the circuit. We have to find current through the 10 ohm resistor. So this is the load resistor RL. Terminals are, these are the terminals A and B. So remove RL and redraw the circuit. Terminal A, terminal B. 2 volt source 1 ohm, 5 ohm, 15 ohm, 4 ampere. Short circuit between terminals A and B. Now current through this short circuit is the Norton current IN. So we have to find out this current IN. In order to find out IN, let's use mesh analysis method. The mesh currents I1, I2 and I3 are marked. And from the first mesh, we can write applying KVL to first mesh. So we will get the relation like this: 2 minus 1 into I1 equal to 0. So we will get I1 is equal to 2 amperes. Then mesh 2 and 3, in between mesh 2 and 3 we are having a current source. So 2 and 3 forms a super mesh. And from here we can write minus I2 plus I3 equals 4 amperes. This equation number 1. Now applying KVL to super mesh. So applying KVL to this mesh. So the equation will be minus 5I2 minus 15I3 is equal to 0. This is equation number 3. Now let's solve equations 2 and 3 for I2 and I3. We will get the value for I2 as minus 3 amperes and I3 is equal to 1 ampere. And our aim is to find out the current IN. And from this circuit it is clear that IN is equal to I1 minus I2. That is equal to 2 minus minus 3, that is 5 amperes. is -3. Then second step, calculation of Rn. Now to calculate Rn, the circuit should be redrawn, replacing the voltage source with a short circuit and the current source is replaced with an open circuit. Here terminal A, terminal B, 5 ohm, 15 ohm. And so it is clear that 15 and 5 are in series, that in parallel with 1. Resistance between A and B is R. So 20 parallel to 1. So we can write Rn is equal to 20 into 1 divided by 20 plus 1, which is equal to 0.95. This much ohms. The next step is to draw the Norton equivalent circuit. N is 5 ampere parallel with Rn. Rn is 0.95 ampere, 0.95 ohms. Terminal A and B. Between A and B, load resistor Rn. Now we have to find out the load current IN using current division. IL. IL is equal to 5 total current into resistance of the other branch divided by total resistance. RL is 10 ohm. That is equal to 0.43 amperes. Let's look into one more program. Find the current through 10 ohm resistor in the given circuit. Here, find current through the 10 ohm resistor. This resistor. So these are the terminals A and B. First step is the calculation of IN. In order to calculate IN, remove the load resistor 10 ohm and place a short circuit between terminals A and B. Then find the short circuit current IN. In order to find out IN, let's use mesh analysis method. So the mesh currents I1, I2, I3 and mark I3. Now let's write the mesh equations. So applying KVL to first mesh. KVL to first mesh, we will do mesh equation 20I1 minus 20I2 is equal to 10. Now that is equation number 1. Then applying KVL to mesh 2. Equation will be minus 20I1 plus 60I2 minus 20I3 is equal to 0. This is equation number 2. Next step is to apply KVL to third mesh. Equation will be minus 20I2 plus 50I3 is equal to minus 100. Equation number 3. Now solve values for after solving we will get I1 as 0.8125 amperes. From the figure it is clear that IN is equal to I1. We got it as 0.8125 amperes. The next thing is to find value for Thevenin resistance. In order to find Thevenin resistance, replace all the voltage sources by a short circuit and find the resistance between terminals A and B. To find out the between resistance R is 40 ohm and this 20 ohm are in parallel but in series with this 10 ohm resistor. So the circuit will come like this and value of this resistor will be 20 parallel to the series is 20. So 600 divided by 50 plus 20, that is 30. Now Rn is 20 parallel to 32. That is equal to 20 into 32 divided by 20 plus 32. That is equal to 12.3. Third step is to draw the Norton equivalent step. Norton equivalent step we convert this 0.8125 ampere in parallel 12.3 ohm resistor and the load resistance 10 ohm is connected like this. Now we have to find out current through the 10 ohm resistor. This is the current I1. And according to current division rule, we can write IN is equal to 0.8125 total current. And the resistance of the other branch which is